Hi guys, so today I want to talk to you about something really powerful and really important. We've been talking a lot about that relationship, that powerful relationship between radicals and exponents, right? They are inverse operations of one another. They cancel each other out. There is this very powerful and strong relationship between the two. Well, today I want to really break it down for you, and I want to show you how you can actually jump back and forth between radical form and exponential form, and why that is such a powerful tool in our study of radicals. So let's get started. I would like to start with this example. It's going to be the fifth root of x to the 20th. Okay, so we're going to look at this and we're really going to break it down conceptually, and we're going to see just how strong that relationship between radicals and exponents are. So let's just take a second and think about what's going on with this problem, right? So we have here x to the 20th, which means that underneath our radical, what's happening? Well, that means we have 20 x's, x times x, right? 20 copies, I should say. I talk a lot about copies. Exponents are like a copy machine. They tell us how many copies to make. Well, here we're being told to make 20 copies. So x times x times x, and that's going to go on and on and on 20 times, right? We're going to have 20 x's underneath that radical. And then we have an index of 5, which indicates that we're pulling out groups of 5. Okay, we want to pull out groups of 5 x's from underneath that radical, right? That's what we're looking for. All right, so we have our 20 copies of x underneath the radical, and we want to start by pulling out groups of 5 in order to simplify this radical expression here. So let's pull out our first group of x's, okay? Let's pull out our first group of x's. So if we pull out our first group of 5, okay, we pull out those first 5 x's. Well, how many copies will we have left underneath our radical? Let's think about that for a second. So we had 20 copies, right? And then we just pulled out 5 of them. So we took away 5 copies of x. How many copies did that leave us with? Well, that will leave us with 15 copies, okay? So when we pull out our group of 5 x's, 5 x's underneath the radical just leaves us with 1 on the outside, right? So let me write that down here. So when we pull out our group of 5, that translates to 1x on the outside, okay? So that leaves us with 1x on the outside of our radical, and then we said 15 copies still left on the inside, and of course we can't forget our index. Okay, so we pulled out our first group of 5. That translated to 1x on the outside, so there it is right here, okay? And when we pulled out those 5 copies, we started with 20, we pulled out 5, so now we have 15 left, okay? It's just to make sure we're all on the same page here, all right? So now we ask ourselves, can we pull out any more groups of 5? We have 15 left, 15 copies of x left. Can we pull out more groups of 5? Well, yeah, of course we can, you guys. We have 15 x's. We can pull out another group of 5. Okay, so let's do that. Let's pull out another group of 5. And when we pull out another group of 5, you guys, that's going to translate to another x on the outside, okay? So that leaves us with, let me get our radical going here. Okay, so the first group of 5 we pulled out gave us 1x on the outside. Well, now we're going to pull out another group of 5. So now we're going to have 2 x's on the outside being multiplied together, okay? How many are going to be left in our radicand? Well, we had 15, okay, right? And now we took out another group of 5. So what is 15 minus 5, you guys? That's going to leave us with 10 copies of x left underneath our radical. So now we're left with x to the 10th in there. Okay, so far so good. So just to recap, we pulled out one group of 5, and that left us with our first x. Then we pulled out a second group of 5, and that left us with our second x on the outside. And after pulling out 2 groups of 5, we have 10 copies of x left on the inside. So again, we ask ourselves, can we pull out another group of 5? Because remember, this index is so important, you guys. It's telling us how many groups of what that we need to pull out. So we're pulling out x's in groups of 5, right? It's telling us we need to look at our radicand and continue to pull out groups of this many. Well, we still have 10 of them. Of course, we can pull out another group of 5. So when we pull out another group of 5, you guys, what's going to happen? Well, we're going to get another x on the outside. So here's our first group of 5 we pulled out. Here's our second group of 5 that we pulled out. And now we're going to pull out another group of 5, okay? Which is going to give us another x on the outside of our radical, okay? And then, of course, we have to ask ourselves, well, what remains inside that radical then? What is our radicand? Do we have anything left? How many x's are there? So let's see. We had 10 x's, right? Now we pulled out another group of 5. How many x's do we have left? We have 5, okay? So now we're left with 5 x's, 5 copies of x's in our radical. Okay. So again, now we have to ask ourselves, right? Our index is telling us we need to pull out from our radicand groups of 5, anything that occurs in a group of 5. I have x to the 5th, which means I have 5 copies of x. So do I have another group of 5 x's I can pull out? I sure do. I have one last group that I can pull out here, you guys. So when I pull out that last group, that's going to give me yet another x on the outside, okay? So we pulled out our first group of 5 to give us 1x, our second group of 5 to give us our second x on the outside, our third group of 5 to give us our third group on the outside, and now I'm going to pull out this fourth group here, okay, which gives me that blue x on the outside. Now, what's left? Okay, so I had 5 copies of x left, and I pulled out another group of 5. Well, then how many are left, you guys? I have no x's left underneath my radical. So if I write that here, right, I have 0 copies of x left. Well, anything to the 0 power, you guys, is what? It's just 1. So this whole piece simplifies to 1. So I'm left with x times x times x. So let me bring that over here. I'm left with all my x's that I pulled out to the outside, right? Each of these represents a group of 5 that we pulled out, okay? So what does that leave us with? X times x times x times x leaves us with x to the 4th. That's 4 copies of x. Again, think of your exponent like a copy maker. So as it turns out, you guys, this radical expression, the 5th root of x to the 20th, simplifies to x to the 4th. And what did we do, you guys? What did we do? We did repeated subtraction, right? We said to ourselves, okay, we're starting with 20 groups of x, or 20 copies of x, and we're pulling out groups of 5, right? Our index told us we need to pull out groups of 5 from that big amount of 20. And so we pulled out our first group of 5, then we pulled out our second group of 5, then we pulled out our third group of 5, and we pulled out our fourth group of 5, right? We kept taking away these groups of 5. Well, guys, what is repeated subtraction? I almost just said it. When you subtract, what is that? What operation is that? Guys, that's division, right? Repeated addition is multiplication. Repeated subtraction is division. We did division. So there is this link between your exponent on the inside and your exponent on the outside, right? What we did was we took our exponent on the inside and we subtracted groups of 5. We divided. So that exponent on the inside, that 20, we divided it by our index. That's the size of the groups that we were pulling out. What's 20 divided by 5, you guys? 4. And that gives us the number of copies we're left with on the outside. So as it turns out, you can use division to jump back and forth between radical and exponential form. And you can use this powerful link between the two to simplify. And using division is going to make your life a lot easier. So in essence, what we did, and I'm going to scroll a little bit just to give myself more room, is we took our x to the 20th and we divided it. We divided that exponent, excuse me, not by 4, silly me. We divided that exponent into groups of 5. And so we're taking the exponent and we're dividing it by the index, right? We divide it by groups of 5. So this is really x to the 20th divided by 5. And what does that leave us with? X to the 4th. So you can jump back and forth between your radical form and your exponential form. We can actually rewrite this radical expression, the 5th root of x to the 20th, as a radical expression, as an exponential expression. And we can write it as x, instead of writing it as the 5th root of x to the 20th, we can write it as x to the 20th divided by 5 power, the 20 divided by 5 power, which is x to the 4th. Okay, so we can use division and we can jump back and forth from radical form to exponential form using division to simplify these expressions a whole lot faster. And that's what we're going to be doing as we move forward. And we're going to talk about that in our next lesson.